let you know, ma'am. And just like give me some time. I will get back to you on this.
Okay, okay, ma'am. It's a test of 25 marks, madam.
It is 25 multiple choice question. So we are going
Huh?
to consider 60% marks to qualify to get the certificate.
Okay, and what is the minimum qualification required in that? How? What is the
60%.
percentage?
Yeah,
50.
60%. 25
Okay,
multiple choice questions. So 60% will be qualifying marks.
okay, fine. Thank you.
Neha ma'am, you have kept a message like sometimes you have joined with other devices, so your name is different. So in this case, you have to intimate us about this by dropping a personal message to us. If like this, if you have done, so we'll find it out in our attendance sheet. Yes, Neha ma'am, did you get it? Okay, thank you. We'll start in another 1 or 2 minutes, sir. We'll start the session. Ma'am is about to join. Good afternoon, Sita ma'am. Ma'am, can you hear me?
Afternoon. I am able to hear you.
Yeah, ma'am. Ma'am, let me
Thank,
introduce you, ma'am.
thank you.
Good afternoon, ma'am. I take the opportunity to welcome Dr. M. Sita, ma'am, as a speaker for today's FDP session. Good afternoon, ma'am. It's an honor and privilege to host you for today's session. Dr. N. Sita is presently working as a professor and head department of CSE in GNITS, Hyderabad. She has a vast teaching experience of 26 years and worked in reputed colleges like CBIT, Hyderabad and Bapatla Engineering College, Bapatla. She has received PhD in Computer Science Engineering in the area of image processing from JNTUH. Her area of research include image processing, soft computing, artificial intelligence, data mining, and optimization algorithm. She has published 154 research papers in various national, international journals and conferences. The number of Google citations are 323, of which Scopus are 75. She has received 3 Best Paper Award in reputed international conferences. She received AICTE CAYT Award in 2009 with a grant of 10.5 lakhs. She has received several prestigious awards such as Acharya Ratna Award, Best HOD of the Year Award, Distinguished Faculty in Engineering Award, and Accenture Star Achiever Award. Without much delay, now I invite Dr. N. Sita ma'am to take over the session on transformation of IoT into data science and deep learning. Over to you, ma'am.
Yeah, thank you, madam, for your kind introduction.
Welcome, ma'am.
Are you able to see the presentation?
Not yet, ma'am. I think it is sharing. Yeah, ma'am. We can see this.
Are the slides moving?
Yeah, ma'am.
Yeah, thank you. So I request all the participants to mute their microphones. So thank you. So thank you for providing me this opportunity to take on the session on transformation of IoT into data science and deep learning. I'm Dr. Sita Maddala, Professor and Head Department of CSC, G. Narayanamma Institute of Technology and Science, Hyderabad. The agenda goes on like this: introduction to Internet of Things data, and the power of combining IoT and AI, which is leading towards the data science, machine learning for data science, algorithms, applications, deep learning, types of deep learning networks, deep learning use cases, research perspective and applications, deep learning meeting the Internet of Things, machine learning versus deep learning, and the conclusions. Let us have a detailed introduction on IoT. Internet of Things is a network of physical objects or things that are embedded with various sensors, the software, and other technologies by connecting and exchanging the data with other devices that are connected via the internet. So if you take the scope of internet from the past years like 2003 to 2020, there are several devices that are connected with respect to mobile phones nowadays and also to various internet technologies. So it has been consistently increasing from 6.3 to 7.6 billion, and the usage of connected devices with respect to various applications also increase in making the decisions. So now we are using various features that are related to decision making also with respect to the surroundings and also environmental changes to various applications. If you see the people, Nowadays, with mobile phone, we are able to connect or control 4 to 5 devices. But in future, we may be able to connect to several devices from 10 to 15 devices. We can operate or control various applications with respect to our mobile phones. Therefore, IoT has emerged an Internet of Things has come out with an emerging technology by taking off the principles of IoT, and it has a broad impact on various organizations, and it also affected various business strategies, the risk management, and wide range of technical areas with respect to architecture and design. So these are the areas or broad areas wherein we have the applications like related to IoT security, IoT analytics, device management, low power and short range of IoT networks, low power and wide area networks, and stream processing with respect to events. This is very, very important applications nowadays people are using in this pandemic situation. Coming to the architecture of the Internet of Things, there are 7 layers. In particular, we can discuss about each and every layer. Layer 1 is related to various devices or things or objects, which consists of sensors, controllers, etc. Layer 2 is related to the edge computing connectivity layer. So whatever the data that we have collected using these sensors, they will be communicated through various platforms which are identified in the layer 2. So these two are under fog layer. Now coming to layer 3, it is a global infrastructure wherein we have the cloud infrastructure related to public, private, hybrid and managed. Layer 4 and 5 are related to data handling and analysis, and it is also given as the big data, wherein we have harvest and storage of things data, whatever we have collected here. Layer 5 is related to reporting and machine learning analysis. So whatever the data we have collected, that we will be analyzing in the case of the layer 4 and 5. 6 and 7 are related to application or the presentation with respect to the business perspective, wherein we have various custom applications using the data that we have collected, and we can also make a decision, and these decisions are have transformed various business application to the different use cases, such that any business strategy you follow or you apply, you can directly use this use case into that particular application with whatever the data you have processed or collected, and finally you have applying to one particular use case. So this is the complete architecture along with the layers description related to the Internet of Things. These are the benefits of IoT, which is able to monitor the overall business processes, improve the customer experience. It also saves time and money, enhance employee productivity. This is the most important factor with respect to the employer perspective. Everywhere you take, it should enhance the employee productivity, and it should integrate and adapt business models, make better business decisions, and also generate more revenue. This is different applications that are shown in this particular slide, wherein we have a smart society which is connected to different devices. Nowadays, we are having smart payments and also smart healthcare, smart buildings, smart transport, smart energy, and also smart territory improvement. So all these are given with smart as a keyword, as in you can control all these devices by a single click, or we can control all these applications with the devices with a single click. These are the further applications that are related to fitness trackers, smart toothbrush, and also gardening shoes. So this is the sample model of various applications related to health monitoring, smart shelves, infant monitors, wherein you can have the monitoring of the kids, whether they have done bedwetting or whether they got temperature. So such type of applications are very becoming popular nowadays. And we can also have the smart refrigerators which can close and open with respect to the smart applications of IoT devices with a single click. So this is a dashboard related to the consumer IoT product and services related to Amazon Dash. And here, along with the dashboard, Amazon Web Services, along with Amazon Market, AWS Marketplace, and AWS SageMaker, they are providing the access to various IoT devices and tools and developing solutions. And being a customer, you can select your own configuration for your project or for your applications. So there are several applications that are available in this AWS dashboard. You can clearly select what is your configuration. You can just drop down it, and you can also buy the application, or you can buy the services, or you can pay the services as per your requirements. So infrastructure is not a big issue nowadays, because it is provided in several web services, or Amazon AWS is a good platform wherein you can utilize these applications. And this is one consumer product that is available to take the temperature data, Kinsa thermometer. By taking this data, it can just give you what is the age of the person. If you just give, it will give the temperature and what is the cause of that temperature. So it may be due to fever and cough. It will also suggest the medicine for that particular problem. So this is just an example for an IoT application. Now let us move ahead. The basic part of IoT, collection of the data. So how to collect, process and analyze the data. So we use three processes or three steps here. The first one is called as sensor data collection. Second one is processing of IoT data. The third one is data analytics. So you can collect the data by using three types. One is automation data, status data, and location data. So here automation data is nothing but it is very essential for processing applications like data related to automation of lights in an office or automatic settings on a thermostat. So whatever the data that is directly provided is called as an automation data. So some automated applications will be available to gather the data. So such data is given as the automation data. The second data is the status data. Most generally, we will be taking this type of data, wherein most IoT devices generate the status data. And this data is called as a raw data, and then it can be used for complex machine learning analysis. And the third one is called a location data. So location data is an indoor global positioning system. So it consists of directing the data to a specific destination, that is the location data will enable you to track the packages or pallets or any spatial coordinates, and that is available in a real time condition. So these type of data will be collected. Most generally, we will be taking the status data. In specific applications, we will be moving for automation data or the location data. So once the data is collected by using these three types or these three methods, we have to standardize and transform the data to a uniform format. That means you have to convert the unstructured data into a structured data. Afterwards, you have to store or create a backup of the newly transformed format, and you have to filter any redundancy of data, repeated, outdated or unwanted data to improve the accuracy. And then you have to integrate additional structured data from different sources to help and to enrich your current data set. So this consists of a lot of transformation to process the collected data set. So after collecting the data, now the power of combining the AI and IoT comes into picture, that is towards data science. So various smart devices may be used to collect the data, and these are again moving towards the data science for the complex analysis. So definitely IoT devices have the possibility to generate a vast amount of data that can be used with artificial intelligence. And since various IoT platforms provide an interface to gather the data from various devices, they can easily be deployed into AI and ML systems. The value of AI in this context is its ability to quickly mangle insights of the data. You can have different types of analysis using the data collected by various devices or objects in the IoT, and also we can collect the data from various smart devices. Now, after collecting the data and processing it, analytics play a lot of role here. So it will allow the data to analyze by varying sets of data, and we can use various automated tools and softwares to analyze this data, and it will again gives the outcome as a customer preferences or choices. Now comes the role of data science into process this data using the machine learning algorithms. So data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge from structural to unstructured data. So you can have the data from different sources. Once the data is in the form of unstructured or structural, whatever it may be, the data should be converted into a structured format. Now, the data science is related to data mining, machine learning, and big data. You have various examples as I mentioned just now. It is used for identification and prediction of disease, and shipping and logistic routes in real time, detection of frauds, healthcare recommendations, automating digital aids, etc. So this is the data science life cycle, wherein you have the first one is the understanding the problem, then utilizing the data mining algorithm. In that you have the data cleaning, data exploration, and extracting the features, so you're selecting the important features, then predictive modeling, data visualization. So this is the normal data science life cycle. So using this, several types of data analytics can be taken. The first one is the prescriptive analytics. These are very important for a time series data or spatial data or any type of data. Based on the data that we have collected, suitable analytics will be utilized for processing the data. So prescriptive analytics is used to analyze which steps to take for a specific situation. It is a combination of descriptive and predictive analysis. Spatial is related to location. Just now I mentioned spatial is related to the locational data. So this is used to analyze location-based IoT data and applications. Streaming analytics is in motion. Generally, we have video analytics here. So streaming analytics sometimes is referred to the event stream processing. So it facilitates the analysis of massive in-motion data sets. Time series data is analytics is related to time series data. So wherein you can have the data that is used for different patterns or trends. So it is a time series means as the time goes on, how the data is retrieved, that is analyzed by using the time series analytics. After analyzing this, the last part is the data visualization. So it refers to the techniques used to communicate and inform by encoding the visual objects. So once you process the data, any form of data visualization using graphs or charts or some other visualization techniques. Nowadays, several visualization techniques are available in market. Tools are also available. So suitable visualization tool can be utilized for effective communication of the analyzed data. So the goal is to communicate information clearly and efficiently and effectively to users. That is the reason now data visualization for Internet of Things is gaining momentum. So there are huge opportunities that are looking for the collected data to provide the better visualization. Therefore, visualization will play an enormous role in assisting and making sense for the new era. Coming to the relation between the artificial intelligence and machine learning. Now, whatever the data and whatever the smart machines that you are considered in IoT, so these are capable of performing intelligent tasks. For this purpose, AI is like a major parent. Under this, we have artificial intelligence, machine learning, and the deep learning steps. Let us see how machine learning is used for the data science. So it involves developing machines that can deliver better results than human, and it will build algorithms and receive input data, and we can use statistical analysis to predict an output while updating outputs as new data becomes available. So here traditional programming you have, and you have machine learning as input and output for particular program. Here we are having machine learning algorithms. In this, the computers will learn to perform and learn. Finally, it will improve the performance. So if you take an example, here is an ordinary system with AI and machine learning. It will learn and it will predict the output. Once the prediction is not up to the satisfaction of the desired output, then it will learn still and it will improve the process and it will have a better prediction. So this is the process of machine learning. There are 7 steps in the machine learning. The first one is gathering the data. Second one is preparing the data. Third one is choosing a particular model. For training, using the model, we will be training the data. Next step is to evaluate the data, whether the evaluation is up to the desired output or not. If it is not desired, you have to fine tune the parameters, and again you have to predict the model. If the prediction is good, okay. Otherwise, you have to follow the same step once again until and unless you have a final prediction. So this training process and parameter tuning will be continuously repeated until and unless you get a better prediction. So these are the main or essential types of learning in the machine learning process. These are very, very important, as you all, many of the participants might be aware of it. But I would like to give you a different perspective with respect to the comparison of this supervised and unsupervised and types of machine learning and deep learning process by the end of this presentation, which will be helpful for the participants in their research perspectives. So coming to the basic definition of supervised, it will take an input and based on the training, it will be generating the output. So it will learn the machine explicitly and it will predict outcomes for future, and it will consider classification and regression problems. Coming to the unsupervised learning, it will understand the data and it will identify the pattern or structure by output. So it will evaluate using quantitative method or an indirect method, and it does not predict or find any specific class. The third one is the reinforcement learning. This is mainly concentrating on the input output based on the rewards. So if reward is given, it is a better learning process. Otherwise, a blame will be given. So it depends upon the state space analysis. So therefore, it will learn how to act in a certain environment and it will try to maximize the reward points rather than the blame points. Rewards are credits, we can say in the different way also. Let us go in depth about the supervised machine learning. So this is an algorithm to map a function from input and an output will be generated. So here the mapping function is selected in such a way that you can clearly predict the output variables for that particular data. And data is labeled. Generally, labeled data is used in the case of a supervised machine learning, and all the algorithms learn to predict the output from the input data. So this is the process of supervised machine learning. This is the data set, which is divided into two types, training and testing. So train model is selected, you will generate a score and evaluate the model. Otherwise, again, you will start. If the evaluation is not up to your satisfaction or up to the desired output, this will again repeat. Score model, then training to score, evaluation, finally the model. These are the various use cases. Use cases are very, very important. So whatever the problem you take nowadays, you should ultimately concentrate on the use case. If there is no use case, then that model or that particular problem may not be coming out with our satisfaction. So therefore, classification has various use cases like fraud detection, email spam detection, diagnostics, image classification, regression has risk assessment and score prediction. And generally, classification problem is when the output variable is of particular category or a class, and regression problem is used when output variable is a real value. So this is the main difference between classification and regression. There are different types of classification problems wherein we can predict the categorical class labels. The first one is the binary classification. Second one is multi-class classification. As you all know, binary classification we are using to divide the set of data into two classes, either 1 or 0. For example, you take an email spam detection, you can derive the class as email as spam or 0. The second one is called as multi-class classification, wherein you have a handwritten character recognition where classes grow from 0 to 9. So this is the example. Suppose you take the circles as one data points and plus marks are another data point. So here we have drawn a linear line to divide this class 1 and class 2. So we have to build a model such that if you draw one line, it should separate class 1 and class 2. So this is called as a boundary line. Suppose a new data point is kept nearer to this particular linear line, it should be able to come into either class 1 or class 2. So this is the problem which can be solved. So now there are two types of concepts here. One is linearly separable and the other one is not linearly separable. In the previous example, we have seen if you draw a single line like this, so this class and this class are able to separate by a single line. So this example is called as a linearly separable class. So whatever the data points you take, if you draw a single line, then those data points are able to follow the linear separable theorem. Suppose if you are not able to have or separate the classes of the data points by drawing a single linear line, then it is called as a non-linearly separable data point. Suppose if you see this by drawing a single line, I can't separate this, but by a single linear line I cannot separate. If I draw a non-linear pattern, something like this, I can separate this. This is another example of non-linear separability. Here also I can draw a circle for this and outer circle for this. So this is not a linear separable. So linear is something like by drawing a linear line, it is called as a linear separable class or linearly separable data points that we can involve in the classification problem. The next one is the logistic regression. So this logistic regression is an important and powerful classification algorithm. So when the classes are not linearly separable, this we can go ahead for the logistic regression. The third one is the decision tree algorithm. This is also one of the example of the supervised classification or supervised learning. So the root node will be selected by the identified features in the data set, and this is narrowed data or narrowed down to have the next prediction. So based on the features of the training set or the data that we have used for training, the decision tree will learn a series of questions to label the classes. Here you all are aware that whenever the important features are not used for the decision tree process, then we will prune this tree. Accordingly, we will eliminate and only we will calculate the information gain and other parameters based on their values only. We will be retaining that feature and all other features will be pruned. In that way, the depth of the decision tree may be controlled. So as I told, the decision tree's hyperparameters are maximum depth and the second one is the maximum number of samples we are going to take, minimum number of samples and maximum number of features. So very often many features are used to build a tree, but if features are very high, then it is expensive and you have to check each and every feature. So hence we will prune the decision tree or we will control the depth of the decision tree without compromising the accuracy of the class that we have identified. This is very popularly used supervised method, that is the random forest. It is used to overcome the drawbacks that are used by the decision tree. So the drawbacks of the decision tree are, if it has lot of features, then algorithm will be going to the concept of overfitting. That means as the training data is increased, the accuracy will be decreasing or diminishing. So that condition is called as the overfitting. So to avoid this overfitting, we will be using the random forest. So we will be selecting each column randomly, and from a decision tree we will have a result 1 and another decision tree we will have a result 2. We'll take another decision tree result n. Like this several decision trees are taken. Finally the results are considered for majority voting like averaging, and we will be producing the final result. So the random forest will be using the ensembling of various methods. So as I mentioned, it will be developing an ensemble learning algorithm which will combine a number of weaker models to build a robust model. So the advantage is more robust to noise and k number of trees are used to tune the model, and larger the k, better the model. But the disadvantage is the computational cost is high. This is one more example of supervised learning. This is also called as a lazy learning algorithm, that is K nearest neighbor, popularly known as KNN. It is also called as the lazy algorithm. It is choosing the number of K, the value of K as a distance metric. So these are the one class of points. These are another class of points. So we have to calculate the distance of the new data point with respect to this class and this class. So this K is the minimum number of points that is nearer to this new data point. Here question mark is a new example to classify. So this should be classified either into this class A or class B. So K equal to 3 means here there are 3 data points nearer to this new data point, and K equal to 7 means total there are 7 data points. So here the selection of K plays a major role in identifying this particular class of the new data point. So based on the distance measures, these distances are calculated by using normal distance formula, and these are sorted, and the class label is allocated by the majority vote. With this classification examples, we will move on to the regression algorithms. So there are several regression algorithms: simple linear regression, multivariate linear regression, polynomial regression, support vector regression. And in all this, the output has a continuous value, and it will predict the target based on the features provided. So this is the data with the input data with the derived features, and it is given to the regression based on the XY relationship or input output relationship. You will be predicting the output. The simple linear regression will follows the formula of y equal to mx plus b. So this is the variable which will be helping in the predicting of the output variable y. So here we have to find a line that best fits the data such that the error is low. So the focus is entirely on finding the relationship between the two continuous variables in the case of the linear regression. You just see, this is an example here. Here we have seen the weight and height of a person. So weight is an independent variable and height is a dependent variable. So it estimates the height of a person using the weight information, using the formula 0.60 into weight. Here we have taken this as an example using this y equal to mx plus b. So using this formula, it will be calculating the weight, and these are the points that are given by drawing a linear weight line here. We can just check how many are nearer to the line. This is multivariate regression. So in this we will be having more than one independent variable. Previously we have only one independent variable, but here we have more than one independent variable, that is y equal to m1 into x1, m2 into x2 and so on. And here also we have to find the best fit that is followed by all these variables. Now we will move on to the unsupervised machine learning. Supervised machine learning is very popular and several algorithms are available there. Coming to the unsupervised learning, so here there will not be any training data and data is unlabeled. So the algorithm should learn independently or by itself to the inherent structure from the input data. So this is the representation of the unsupervised learning as an example. So all raw data will be there. We will be using an algorithm. Based on this algorithm, the data will be clustered. The major example of unsupervised learning is clustering. So you can see here all jumbled data, which is a raw data. So using this algorithm, this will self-learn by itself. It will learn all the patterns, and accordingly the clustering will be performed. So the data is divided into independent patterns. So this is the definition of clustering. We're grouping the points into some number of clusters, and it will determine the internal grouping of unlabeled data. So this is an unlabeled data. Later it will group into birds and parrot fishes. So there are 3 fishes and 3 birds. So by unsupervised learning algorithm, this is divided into 2 clusters. The major or the popular example of unsupervised learning is the clustering. And again, in this, we'll be using a k-means clustering. So it will partition the data into k number of mutually exclusive clusters. So it will divide, or it will have a point that is fitting into the cluster, and also it will determine the distance between the particular point and the center of the cluster. And it is popularly used when the number of clusters is known, and here also the selection of k depends on the algorithm. If the selection is done perfectly, then we can have a better grouping of the data or better clustering of the data. So as you can see here, for example, we have used k-means clustering for signal processing and in features learning. This is about the sepal length and sepal width for a particular data set, and accordingly you can divide into various colors. This is of sepal length and sepal width. This is the consolidated information related to supervised and unsupervised machine learning. So we have a supervised regression, linear regression, polynomial regression, and random forest, decision tree, KNN, logistic regression, and naive-based and SVM is not dealt here. These are also the examples of the classification of supervised learning. Then in unsupervised, we have single value decomposition, principal component analysis. These 2 are not dealt. I had gone only with k-means clustering, and also the association analysis. We can have a priori and FP growth and hidden Markov models. These are also related to the classification with respect to categorical data. This is the detailed comparison between the supervised learning and unsupervised learning with respect to various parameters. The parameters mentioned here are process. So here supervised will have input and output variables, and in unsupervised only input data is given. In input data, supervised will have algorithms using labeled data, and here they are not labeled. Real-time learning takes place offline here. Here also learning method takes place in real time. Computational complexity is simpler in the case of supervised learning, and here it is complex. Use of training data between input and output, it does not use any training, or it will not have any output data, unsupervised learning. Accuracy of results are very high in the case of supervised, because you have the training data, and the data is also trustworthy method. But here it is less accurate and less trustworthy, because you do not know whatever the feature it is identified, accordingly the cluster will be given. And this is the main drawback of the supervised. Classifying big data can be a real challenge, because training becomes very, very complex in this case. And here it cannot get precise information, as the supervised learning labeled data is not known. As I told already, it is a less trustworthy method and it is a less accurate method. But however, sometimes we can combine. That means we can have a unsupervised method and get a data, and this data can be used for training in the case of the supervised. That means unsupervised learning can be given as an supervised machine learning based on the application, because there is no guarantee for us always we are available with the training data. Sometimes for an unknown applications we may not have the training data or we may not know about the data. In such case, definitely you can use an unsupervised learning method, and you can divide or you can identify few patterns. As a trial method, these identified patterns can be given as an input to the supervised learning, and you can test the accuracy. So these are the various machine learning applications related to supervised. Again, supervised has regression and classification. This is unsupervised. In unsupervised learning, the basic steps are dimensionality reduction and clustering. So as I told, dimensionality reduction, we will be using single value decomposition and PCA. I have not gone into that topic. So I have gone through the clustering application, and the next one is the reinforcement learning, wherein we have gaming, skill acquisition, and robot navigation. The next topic, continuation with respect to data science using machine learning, is the deep learning. So now let us see the differences between the machine learning and deep learning. So how it became popularized with respect to the machine learning. So deep field is a subfield of the machine learning that is concerned with the algorithms inspired by a brain structure and functions known as ANN. And if you see the difference in machine learning, we will be extracting the features, then classification. But here both feature extraction and classification is performed in this processing deep learning element. If you give an input as a parrot, it will extract the features of the parrot and classify it, and finally the output is given as a parrot or not parrot. So this is the intuition behind the deep learning. So deep learning is a machine learning method that takes an input X and use it to predict an output Y. For example, if you take the stock prices of the past week as an input, the deep learning algorithm will try to predict the stock price for the next day. So very fastly it will predict based on the data that is processed using the deep learning, and it will try to minimize always the difference between the prediction and the expected output. So when you have deep learning algorithms, naturally the question arises, so what type of learning pattern or how the processing is done. So the basic backbone for the processing of all the deep learning is nothing but the neural networks. So using neural networks, we are able to find the association between the set of inputs and output. So these are the processing element with respect to activation function. Actually, neural networks is not a new topic. It has been used from the past 20 years. But because of this artificial intelligence and deep learning, and because of the extended deep learning networks, again neural networks became popularized from the past 10 years. So here we have this X0 and X1 and X2. This is called as a bias. And here we are having X1 and X2 as an input. So this is having the summation, that is Wi into Xi. We have the weighted sum of one particular input into its associated weights plus bias function. This is called as the activation function. Based on this activation function, the output will be decided. So here we are having various activation functions which will be dealt in the next slide. So this is the deep learning process. We have to understand the problem and identify the data, select the particular deep learning algorithm, then train the model, finally test the model. So these are all the layers of the deep learning network. So you take one particular input. In normal neural networks, we will be using one hidden layer and one input layer and output layer. But in deep learning networks, we will be using several hidden layers and several other deep layers in order to produce the output. So this is just an example for the perception of neural network in deep learning. Coming to the deep neural networks, again you have two types, supervised and unsupervised. In supervised, we have neural networks, artificial neural networks, convolution neural networks, and recurrent neural networks. Coming to unsupervised, we have self-organizing maps and deep Boltzmann machine and auto encoders. So these are the applications for this. ANN is used for regression and classification. CNN is used for computer vision applications, and RNN is used for time series analysis. Whereas in unsupervised, SOMs are used for feature detection. These two are used for recommendation systems. Several recommendation systems are the popular applications nowadays. So using this unsupervised deep learning networks, we can develop this recommendation system. So as I mentioned, this is the model of the artificial neural network working condition. So several inputs are given with associated weights. So this is the input function, that is sigma of Wi into xi. This is the bias. So based on this, the activation function will be working. And if this value is greater than this particular activation function, then output will be given. You can see various activation functions here. We have a sigmoid function, we have tan x tangent function, and ReLU. ReLU is nothing but rectified linear unit. Then we have leaky rectified linear unit. So you can clearly see here, if the value is greater than this, then the output is 0. Sorry, if the value is greater than 0, then you have an output. Otherwise, if it is less than 0, you have a output as 0. So based on this activation functions, the output of the neural network is generated. So these are all the equations which are already aware of this. Just I would like to again go ahead with this practical animation. So this is a cat and a dog. So you can have an input. So you have one input unit and another output unit. So these are one hidden layer is there. So just like the weight associated, the network will be learning unless and until you get a desired output. So previously we have various alphabets or various combinations are generated here. Finally, if it is dog, because our target is dog, if you receive this as dog, then the network will stop. Training the network will be stopping. Then in neural network, the next one is recurrent neural networks. We have just discussed this. Recurrent neural networks will be used for time series analysis. So there are several prediction problems like one to many, many to one, and many to many. One to many is having an input mapped to a sequence of data with multiple steps as an output. And we also have many to one, wherein multiple steps are given into a single output. Many to many, a sequence of multiple steps of input are mapped to multiple steps as output. So based on the application, we will be using one particular model. So these recurrent neural networks will learn patterns from the sequences of data, whatever we have considered in the top, such as text or handwriting or any spoken word. And finally, it will be taking as the time series data. And you can take an input and this input will be perceived as one step back at the same time as an input. And generally, these recurrent networks will be concentrating on the memory. So because it is a time series data, it requires lot of memory to process. So therefore, based on the current and previous inputs and based on the memory constraints, this model will be working. So you can just see this is output, and finally with all the constraints, it is going to generate the output. So this is just a predicted output. It also depends upon the other factors in order to validate that particular output or not. The best RNN is for the short term memory. This is the problem that we are going to generate with the help of the or with the use of the recurrent neural network. So to overcome this, we will be using the gated recurrent unit. So the best network here is the gated recurrent unit to overcome this memory problem. And this is the working of the long short-term memory along with the gated unit. So we will be using internal mechanism called gates here. So these gates will be regulating the flow of information. Based on the input, this gate will control the output, and accordingly that information will be given to the next gate. For example, here each output is dependent on the previous cell state and forget gate, and also the new cell state. So major idea of the recurrent neural networks is the output is dependent upon the previous cell state. So here we have different applications like speech recognition, speech synthesis, text generation, etc. The next important deep learning technique is the convolution neural networks. This is also very popularly used in several applications. Nowadays, whatever the application the people are doing, they are utilizing convolution neural networks. But here I would like to mention one point. For all deep learning applications, the data should be very, very high, because you are giving the data to the process, and the network itself is identifying the features and it is also classifying. So if you take normal data or the data size of minimum memory, and if you want to utilize deep learning algorithm, it doesn't make any sense, right? So if you take a very, very big data or large data wherein it can automatically extract the features and it should classify, then it is always suggested to go ahead with the deep learning. Nowadays, several like student projects, if you take, or the research projects, whenever they come for any presentation, we can clearly see that the data that they are utilizing is very, very small. So for deep learning application, the data collection itself is very, very essential. That is the reason IoT, if it is transformed to deep learning application, the challenge lies in collecting the data and transforming the data into a structured format. Applications are available directly wherever you go. As I told you, take a AWS SageMaker or AWS Marketplace, wherever you go, you can develop an application by selecting the infrastructure or selecting the configuration, whatever you want. If you want any GPU, you can select there. If you want any model, deep learning model, you can select there. Directly you can use it. But to use that particular model, you should have the data. So this is a challenge. You cannot say, or you cannot download the data for normal data size and memory. We are using a deep learning algorithm. For that, a normal data mining algorithm is sufficient. You need not go ahead with a machine learning also. If at all you are using a machine learning, at least you should have minimum size of data and you are predicting. Then if data is very high, then only you go ahead with the deep learning, or at least you should justify why we are using deep learning. In deep learning, why we are using this recurrent neural network or convolution neural network or other things in order to implement or in order to have a particular application. So now coming to the description of the convolution neural network, it is designed to map image data to an output variable, and it will allows the model to learn a position and scale of various structures in the data, and it will work better for a spatial relationship. Spatial means the location. So CNN is traditionally a two-dimensional field or a matrix, and it is also changed. It can also be changed to one-dimensional, and it is basically designed to recognize visual patterns directly from pixel images with minimal processing. So this is the architecture of the basic convolution neural network with one example. This is an input. So these are the various feature maps that are generated at different convolution layers. Finally, the max pooling is done and output is generated. So different features at low level, mid level, high level are selected at various layers. Convolution neural network will be having various layers and different level of features are generated. Finally, a better feature is identified and that will be trained to a classifier. So with this basics, let us see the types. Again, as I told, we have CNN. These are the variates and neural network structure application. For CNN, we have LeNet and LXNet, VGGNet, RNN, LSTM. This is GAN, Generative Adversarial Networks. This I have not done, just I gave you for information. So in this, the examples are DC GAN. Here we have input layer, convolution layer, pooling layer, fully connected layer. In RNN, we have input, hidden and output. Here we have discrimination model and generation model. These are the applications: image processing, signal processing, speech, NLP, time series, emotional and NLP, image generation and video generation. Now, these are the various architectures that are used: LXNet, ImageNet, ResNet, and VGGNet for convolution neural networks. Several applications now people are doing in this using these networks. So this is the LXNet is the first deep neural networks or deep learning network. It has a activation function I mentioned previously. This is the rectified linear unit. This is the activation function that is used. So the major difference lies in identification of the convolution layers and the activation function. Based on that, the output is varying. In all these networks, whatever architectures I have defined here, the major difference lies in the selection of the convolution layers and whether it is fully connected or not. Here it is 5 convolution layers with 3 fully connected layers, and we will use rectified linear unit for the linear part. And here ReLU is a faster activation function compared to sigmoid that is we are using. And this is the derivative of sigmoid, and it will become very, very small when you go for the weight updation. So we can have this, we can reduce the gradient descent problem. And it also addresses the overfitting problem by using data augmentation and dropout. So it consists of 11 by 11, 5 by 5, and 3 by 3 convolutions, max pooling, dropout, data augmentation, etc. Now ImageNet, here we are using. This you can see here, we are having different layers for max pooling. And finally, this is the large data set, and it is used for annotated photographs. And this is the challenge that is the package used for ImageNet large scale visual recognition challenge. Then generally this is used for 1000 categories and we will have 1.2 million images in this particular challenge. The next one is VGGNet. It is Visual Geometry Group. VGG means it has 13 convolution and 3 fully connected layers. And here also the activation function is ReLU. And it will have more network stacks and more layers onto AlexNet. So it will have more use of smaller size filters of 2 by 2 into 3 by 3. So using these filters, the exact features are max pooled and finally the output is given. So as I told here, the extraction of features will be done at different layers and finally the probability of the exact features is considered. The last one is ResNet. ResNet is called as Residual Neural Network. It is a novel architecture with skip connections and features with a heavy batch normalization. So here skip connections are also known as gated units or recurrent units. So whatever the output that is generated, it is again fed back to the next unit and it will train a network with 152 layers. And it is even though it is training 152 layers, it still have a lower complexity than the VGGNet because of this recurrent nature. So these are the use cases for ANN, CNN and RNN. Most popularly, people are using the CNN for image data, classification, regression and object detection. Object detection using videos has become a very, very important research area nowadays. And RNN is used for text data, speech data, and also for classification, regression. This GAN is now emerging for various applications. So these applications are also, or these models are also used for several problems in the current scenario. So finally, I would like to have a comparison of all these deep learning networks of CNN, RNN. So CNN will automatically detect the important features without any human supervision, and it will share its weights, and it has very high accuracy in image recognition problems. Coming to RNN, it remembers each and every information through time because it is basically useful for time series prediction. I'm just talking about advantages first. Then LSTM will partially solve the vanishing gradient problem, and GAN will generate samples faster as there is no need to generate different entries in the sample, and GANs don't need approximations to train, and also they don't introduce deterministic bias. That is the reason this generative adversarial networks are becoming popular. Coming to disadvantages, CNN will not encode and the position and orientation, and it will requires lots of training data. As I mentioned, it requires lots of training data. The problem is with RNN is it will vanishing gradient and exploding problems is not properly considered here. Training of RNN is very difficult and it will take long sequences. LSTM suffers with exploding gradient problem and it also requires lot of time and it will suffer the problem of random weight initializations and it will have more overfitting. So this GANs will be having a problem of having a good equilibrium, and it is also the training is unstable and it is very hard to generate discrete data like text, and it also have another probability or problems with respect to identification the probabilities of the pixels. Okay, applications I dealt already. So finally, I would like to just show some applications that we have developed. with respect to IoT and deep learning. We have developed applications with respect to environmental monitoring. So this is the various temperature monitoring classes that we have considered, like windy, humidity. Based on this, we are able to identify the weather conditions. And this is a energy based application. We have created some smart energy meters, and based on this energy monitoring system, we are able to identify whether we are having this temperature in different at different places related to household activities in kitchen, living room. We are able to control the temperature using the smart home application. And this is not a developed, but I have taken this for a use case for an Internet of Things analytics application for consumer product utilization based on the marketing. So if you take a product, it will identify how effectively the sales are going to done, and it will also give an analytics. So it is also used for barcode, QR code, RFID. Finally, it is used for a particular smart platform, and it also used for logistic and supply chain optimization. These are just taken from the existing thing. I would like to show our applications. Yeah, this is what the video analytics we have done. Suppose if the car is going on or any video is going on and moving objects are there, we are able to identify the analytics or whether car is in which position at which place. So this is the output that is generated. This is called as locational analytics. And we could also identify the license plate. We performed license plate detection and we identified the number using this CNN. So we trained various plates. So we are able to identify the image and as well as the text in this number. So a box bonding is created for the object, and then it is identifying it as a plate and also the number on the plate. And this is the one more example using convolution neural network. We are able to predict the age of a person and emotion and also gender of the person. If you give this input like this, it is giving as a male, and also the age and also the emotion. So all these emotions are trained. If more training data is given, you can get a better accuracy. This is the pest control that we have done on the leaf of the crop. We could identify the disease of the leaf. And this is another project we have done on identification of wishing and non-wishing images using recurrent convolution neural networks. So we have combined these two. So people are facing the problem of good morning and any wishing images. So a lot of memory is wasted in mobile phones. So we would like to identify the wishing images and non-wishing images. So wishing images can be deleted by just pressing one particular click. So to identify that, we have identified the good morning, happy Thursday, happy Monday, have a nice day. Like this, we have identified the text and also the identify the images. So by taking the image detection, we have first removed the images. So generally, if any wanted photographs or wanted images are there, so they will be preserved. Any unwanted wishing images can be deleted. So this is the project on identification of wishing and non-wishing images using RCNN. And this is one more project we have done on text detection from videos. So we have taken the detection of text on any video. Suppose this is the container that is going on. If I want to identify the text on this container, So the first box bounding will be given, then this text will be retrieved. So this is also on different data sets we have taken. Suppose this is the supermarket, in this Oreo biscuits are there. So if in this image we would like to detect what is the text on the image. So for all these applications, we would like to have the structured data, and also structured data should be retrieved from the unstructured data, and we have to train several images. So no doubt we can use CNNs if you have lot of training data, training and also labeling. If you give, this feature will be identified and you can generate an output. So therefore we have performed various pre-processing steps to identify various this text candidates. See, this is what detection and bounding box, anchor based approach to locate the text labels in a supermarket. So we can also use forward recurrence CNN to detect these texts. Several applications are there. This is centroid detection of the targeted object. Suppose these are moving videos. Based on the centroid of the target, we can identify whether what position this will occupy in the next moment. So after 1 minute, what will be the position of this target in the moving video. So some applications will be there to identify the position of the object, or to identify the trajectory of the target. For such application also we can calculate the centroid of the target. And this is an application for annotating the images. This is very important application for CNN. Suppose if you take any input, you can annotate the image this as a swan, or you can annotate this image as a cup, and you have to train the data. So for sometimes this annotation is not so easy. So I would like to put forward for all the participants, several annotation tools are also available, like VGG image annotator. And using this we can annotate the image. Suppose this we are able to identify it as a cup, and we are breaking the egg or pouring the liquid. So each and every action can be annotated, and using these annotations we can train the network. We can also annotate the human beings by taking the box bounding. So this is the name of this particular person which is annotated. And with this we can also use the moving object detection. We can also get like this is a moving car, and we are also able to get the height and width of the car, and also the accuracy of the prediction of the car is also displayed. The numerical that is displayed here is nothing but the accuracy of that particular car. So now I would like to end my presentation with the differences between the machine learning and deep learning. Again, in machine learning, we have various parameters, data dependencies, hardware dependencies, feature engineering, execution time, and interpretability. So the data dependencies are excellent for small and medium data set. For deep learning, it will show excellent performance only on big data set. And hardware dependencies means it will work on a low-end machine, but for deep learning applications, you require a powerful machine, preferably GPU. And feature engineering, we need to understand the features in the case of machine learning. We need not understand the feature in the case of the machine learning, because feature identification and classification will be taken care by the deep learning approach. Execution time is very less in the sense compared to data mining application, it will take few minutes to hours, but deep learning will take up to weeks. Sometimes if you keep a training for a network, to train it will take some weeks. So neural network needs to compute significant amount of weights. I showed the the sample animation. So it has to train. So that is the reason if you nowadays if you send any medical report for biopsy or for some rare like diseases, sometimes it will take 1 week or 10 days to get a report. So internally it has to perform several computations when a test sample is given. The last one is the interpretability parameter. Here we need to have several algorithms and these are easy to interpret. For example, like logistic decision tree, and some are almost impossible in the case of the machine learning. And in deep learning, everything is possible, so it is difficult to be impossible. So this is machine learning versus deep learning. The major thing here, machine learning has feature extraction separately and classification separately. Here, these two are combined in the case of the deep learning architecture. So why deep learning is very, very important means the major task is only the performance and it can work on the large amount of data. So as the amount of data is increased, we can observe there is a clear-cut improvement in the performance compared to the other machine learning algorithms. Hence, people are moving to the deep learning. But as I suggested, the application also is very, very important when you move to deep learning. So finally, conclusions, deep learning meets the Internet of Things. So applying various data science scenarios like machine learning and deep learning neural networks to IoT device. Nowadays, it is able to transform various generation of applications performing complex sensing and recognition tasks to support new realm of interactions between humans and their physical surroundings. So hence, with this new invention, people are developing applications, hope to see better and sustained and useful use cases with deep learning and machine learning in future. So I wish you all the best for all the participants and thank you for your patience listening. So I see more and more people will start research in these areas and go ahead for your objectives. So thank you very much. Thank you for all the participants. And once again, thank you for the organizers for giving me this opportunity. Thank you.
I request the participants if you have any queries, you can ask ma'am. Any queries from our participants?
Yes, any queries from the participants?
Okay, ma'am, we'll end up.
Okay, thank you.
Thank you, ma'am, for the wonderful session. We appreciate your approach to anticipate the research intents. We are grateful for the time and effort you took to share your thoughts and experiences in the applications of IoT-based deep learning. On behalf of all the participants, thank you, ma'am, for the informative session.
Thank you. Thank you once again.
Dear participants, as now we have come to an end of online Atal IoT FDP, I, Shamil Telkar, would like to thank all the participants for your suggestion, continuous cooperation and unwavering attention throughout this program. Thank you one and all. Next session will log in at 2 o'clock. So at 2 o'clock I'll share your quiz link so you can take the quiz. Please be on time. Thank you.